Continuing on from in lesson 11, and we're looking at where compounds per year occur less often than payments per year. Now this one here, the answer to me, I'm not entirely sure actually what the answer is here. I've got a few good guesses of what the answer is, and I think we're going to find in this video why I'm not so sure. So I've definitely highlighted this. This is a rarer question, and we're going to go through a few different answers for the same question. They occur less often, but I think one of the past tests does have one like this. Let's just go through it, use a finance app, accept that that's the answer, and then go through some other ways of doing it. And we'll just have a chat about that really. So rule of thumb, if the compounds per year occur less often than the payments per year, go straight to the ClassPad app. Okay, so let's just look at our scenario here. So suppose that $250,000 is invested into an account paying 8% interest compounded annually. So we can see compounds per year is 1, with $10,000 withdrawn from the account 3 months later and a further $10,000 each quarter thereafter. So payments per year is 4. So we can see here that payments per year occur more often than compounds per year, or vice versa. Use the finance app to determine the balance after 3 years. And it does say confirm your answer using a recursive rule. We are going to just cross that out because it just doesn't make any sense using our formula for the recursive rule. Do you remember up here? Really only use this when you've got the compounds per year exceeding the payments per year. It doesn't make any sense when it goes the other way around. Okay, so let's get straight into this. So the compound interest app, we've got N, I, and you just want to write down all this. Now, this is important as well. When you're doing a test or something like that, just literally write down what you're putting into the finance app. It's just basically your working, so very, very useful. And I'm just getting to that page now. Okay, I, PV, PMT, FV, payments per year, and compounds per year. So let's go I's 8%. The PV, it's an investment, so negative $250,000. The payments, they're withdrawing $10,000 every, was it quarter? Sorry, I should go there. And the compounds per year occur annually. Now we're trying to work out the FV. What would be the N? Well, the N in this case, you've got 4 payments per year times by the number of years, which is 3, so 12. Okay, so let's jump into the finance app and find out what the FV is there. Okay, so here we go. Finance app. Got that there. I've plugged them all in. I've tapped FV and out pops $181,238.78. And so we just put that answer in. 181,238.78. As always, I'd recommend stating it after 3 years. The balance is, 181,238.75, but if you're rushing a test, that's absolutely fine. 0.78. Can't read my own writing. So if you're pushing a test, obviously, you can just leave it like that. So we've got our answers there. Now, I said that this may be a little confusing. I was just wondering how the finance app was calculating it. So I had to think about, how's it calculating this? And so I just did it manually. And I made a little graph out of it. I like to show these graphs as a way of just sort of representing what's happening in your bank balance. So this is your balance A, and T is time. So what happens is you start off on 250K, right? And then we'll mark these off 6, 7, 8, 9, 10, 11, 12. So there's going to be 12 compounding or withdrawal events occurring before you have the before it's 3 years, so 3 quarters. So if you want to think about it, this is like, quarter 1, quarter 2, quarter 3, quarter 4, and this is the first year. This is quarter 1, quarter 2, quarter 3, quarter 4. This is the second year. And this is quarter 1, quarter 2, quarter 3, and quarter 4, and this is the third year. So I had to think about it, and this is how I was thinking about how this balance is going. I just wanted to compare, is $181,000 similar to this method? So you're at $250,000 in your account. When you hit the first quarter, what's happening? You're withdrawing 10K and you haven't earned any interest. So it's going to drop by 10K, right? Then, so you're on 240,000. It gets to the next quarter, you drop 10K, you're earning no compound interest. Go to the next quarter, dropping 10K. Go to the next quarter, dropping 10K. Now, I'm going to move that 10K. At the end of that last quarter, what happens? You do get your interest, okay? So at this point, you're also going to see your balance rise by the interest you're earning, okay? Now, whatever this amount is here, we're going to times that value by 1.08 because you're getting 8%, so it's going to increase by 8%. Then what's going to happen after that? It's going to step down again. So next quarter, there it is, there. Sorry, it's the diagram here. Anyway, so you're going to see the step function, down again, down again, down again, down again, then up. Oh, that should be with that one there. So it jumps straight back up again. So you times by 1.08 again. And then you get the same staircase step function thing. And then it's going to increase one final time. Okay, now at this point here, that's your A12. This is what's the balance after 12 quarters. So with this in mind, we could try to run this calc instead. Now how this calc's run is going to be something like this, and I made it a bit of space for this one, so I might just clear out some space. So it goes like this. A0 starts off 250K. A1, right, and this is going to be the end of the first year, okay? So end of the first year, what's happening? You've got 250K, then you minus off the 40K you've taken out, so that's like going from there to there, that's minus 40K because there's 4 lots of 10K, then you times that answer by 1.08, or you're increasing it by 8%, that's the interest you're getting, and so that number will come out to be 226800, right? Now, to get the second year, what do? A2, you're going to do 226800, take another 40K, times by 1.08, and out will pop your next number, 201744, okay? That's the balance after 2 years. Let's find that final one. Let's switch to green. Third year, A3, 201744 minus another 40K. We times by 1.08, and out pops an answer of 174,683.52. Now, that answer I've got using this method. I'm not 100% sure. Maybe I don't understand the complete inner workings of how compound interest works, but that number to me is quite convincing. But you can see here, it doesn't match up with how the ClassPad's doing it. Not sure what the ClassPad's doing. That's one way that I'm thinking about it, and to me, that answer I've just made is more convincing than this one, just because I can see where it comes from. I'm not sure what's actually happening in the ClassPad. Now with that, I just wanted to investigate, and I went on a bit of a internet search and found some more compound interest apps with withdrawals, and these are the results I got. On compoundinginterestcalculator.com, what a classic website. I think we've all visited that. 250K, we can see that there. Negative $10,000, you're taking out 10,000. Quarterly, 8% over 3 years. Compound frequency is annual. That's your final balance, 178. So we can see here, we've now got 181, 174, and 178, cool. Another one, which is from the calculator site, $250,000, 8% 3 years, compound into yearly, and then 10K quarterly, and the amount we get is 181,176.32. So which one is correct? I'm not really sure. I mean, that one there, 181,176, and this answer over here is quite similar, but overall, I'm not entirely sure. Personally, I think you couldn't take marks off of this. So I think the class pad, you'll definitely get, I think, full marks for that one. And I'd be leaning towards that method versus this one, although I think that this strategy, personally, is more convincing. So I know this video probably might not help you that much, but the rule of thumb, just you grab that finance app as soon as you see the compounds per year occurs less often than the payments per year, okay? It's just an alarm bell. Whenever you see that, just grab for the finance app. Thank you. Hopefully this video was useful, and thanks for watching.